So today we'll be presenting about our project for data structure and algorithm course. We have research about VS Code. So on the screen right now is the team members and their student IDs. So application and description. Visual Studio Code, or commonly known as the VS Code, is a lightweight, extensible open source code editor. It supports syntax highlighting, debugging, Git integration, extensions, and more. It ranges from languages such as Java, JavaScript, PHP, HTML, C, C Sharp, and so on. And on to the next presenter.
I will be explaining how the application VS Code works. Now, it's important to note that in VS Code, there is many different kinds of operations being a code editing software. However, for the purposes of our presentation, we chose three operations to present and briefly explain before we get into the primary data structure that we choose to present the algorithm for, and those being folder and file tree navigation, task scheduling, and undos and redos. These three operations have a data structure associated with them. Now, the first one that I'll briefly explain is the folder or file tree navigation. The data structure used here is trees, and primarily depth first search and breadth first search for its navigation. Now, as you can see in the dashboard for VS Code, on the left side of it, you can see there is a tab that is called Explorer, and it's used for navigating through different codes and folders which you want to open for code editing. And in this context, the tree structure for this file navigation comprises of nodes and node children. The nodes being the file or folder, and node children is the files or more folders that are inside the root file. So a file node with no children can be considered a leaf in this context. As you can see, the folder up here is the root, which is like the base folder for your coding project, and then the node is another folder that is the child for the root, and then the leaves are the files or the codings inside the folder that have no child. Now, second one is task scheduling. This is another operation, and it's kind of the universal concept for every execution or operation that is happening inside VS Code. Tasks and operations in general in VS Code are queued for execution. So this is to ensure operations are in order, so newer processes don't run until old ones are done. The most basic form of this is when you are typing. Logically, every time you type, there is always a queue to what you are typing, so there's no overlapping. Therefore, tasks at the front of the queue are always executed first, whether you are saving something or deleting something, or if you want to copy and paste a certain code in the code editing software, there is always a queue to it. So therefore, the order is in, first out. Now, the last operation that we'll be looking forward to, and is the one that we chose to explain further in depth later on, is undos and redos. This operation involves stack data structure. So to keep it short, as we all know, undo means reversing the last action, and redo means reapplying the action that was undone. So practically in VS Code, and in this context of stack, this will involve two data structures, which is the undo stack and the redo stack. So logically, undo stack stores history of actions in the code, while redo stack stores actions that were undone and can be redone. So you can imagine that undo stack is like the history of what the user does in the application, not like the absolute everything action. Like, it doesn't detect clicking or scrolling. It will detect like inputs or outputs that the user has done, so you can undo them. And the redo stack is like the stack that keeps track of the undo stack. So if you want to undo something but you later think that you want to undo what you undo, then you can redo what you have done. So it's like a restoration. So each editor in VS Code contains two stacks, so that's simple. So in VS Code, you can have different codes to open and edit at once. So these two stacks will be unique to that particular code. So these tags involve the last in first out principle. So new elements are added on top and are therefore removed first when the stack is called that way. The principle is good for undos and redos because logically, if you are doing a coding or doing certain actions, it's good to have last in first out because logically, if you want to undo something, you want to undo the latest thing that you have done. So it is not like this is not undos and redos do not work if you want to use for queue because if you're doing a queue, it will undo the furthest thing that you have undid. So like the first thing that you did in the program, and if you are already further into the program, it will only undo the things that you have done long ago. So logically, if you undo, you want to undo the thing that you just did. So when the user makes an edit, it's pushed onto the undo stack, and then the redo stack is cleared. And when the user hits undo, the top of the undo stack is popped, the inverse of the command is applied, and the command is pushed onto the redo stack. So as you can see, if you undo something, you can imagine that as a pop operation for popping the action that you want to erase. But that popping will also be kept tracked or traced by the redo stack. When the user hits redo, it pops from the redo stack and reapplies the command and pushes it back into the undo stack. So there is two pop operation. There's one pop operation for the undo stack, and for the redo stack, it can push back what you just popped. So this gives very many options for the user, so that they can erase what they did, and also redo them just in case. The undo stack keeps many forms of input from the user, so it's not just typing. It can also keep track of what you deleted, what you pasted, and what you grouped together inside the code editing software. That's all from me. Thank you.
Assalamualaikum and warahmatullahi wabarakatuh. Now I will continue our presentation, which is presenting operation algorithm in Visual Code Studio. Next, I will present Visual Code undo and redo system by using a step. Okay, so let's into how does undo work. Every time you perform actions such as this example as when you such as I give you an example when you typing A, the system create an object represent the action. For example, the my action be stored as insert char A. This action then push onto the stack called the undo stack because the stack is leave last in first out leave here. The most recent action is always on the stop. When you press undo button, the system pop the first and the top action from the undo stack, which is in reverse reaction. If you insert A, it will delete A. Then the system push the action onto a second step, the redo stack, in case you want to redo it later. Okay, this method ensure we don't lose data and every action can be cleanly reversed and redone. Okay, next I will give you example of surrogate of undo operation. Okay, let's take a simple example with this three action. Okay, when you insert A, it goes into undo stack A. When you insert B, it also added to undo stack. When you delete A, it also to added to undo stack. Now the undo stack look like this. Insert A, insert B, and delete A. The most recent action is delete A is on top. When we hit the undo button, the system pop the delete A from the undo stack. It will reverse, that means insert A, then push the reverse action to redo stack. Next, here how the procedure code look. Okay, the function double column, if undo stack is not empty, action equal to undo stack of apply reverse action, redo stack, and push action. Okay, next I will continue with the time complexity of undo process. Okay, this is the example of undo process, undo methods such as undo stack, redo operation, linked list, undo persistent, undo transitional undo, and advanced document undo. Basic undo, which is stack level 01, time which is time capacity 01, redo to stack and redo 012, linked list undo, double linked list, which is time capacity 01, and percent undo version data structure 01, time capacity database problem log 08, and advanced document undo, common pattern or change list, which is 0 and K. Let's go to the next step, which is time complex of analytics. Okay, let's visualize what I have described in that table format. Okay, operation descriptions, time and complexity. Okay, when we hit the push button is store the action into the under step, which is time complexity of 0, 1. When we pop, it will be remove the last action, which is time complexity 0, 1, and get inverse, which is compute the reverse of an action, which is 0, 1 of action. Undo, which is apply inverse action, which is 0, 1, 2 time complexity, and redo, reapply previous undone section 0, 1. This is the consistency of efficiency is wise that are preferred in real-time environment like in code editor, graphic tool, and stat processing. Okay, next, I will explain how why that is very suitable for undo. Okay, first of all is LIFO behavior itself, because the most recent change is the first to be undone. This is exactly on how stack is worked, and so, okay, and the second is quick and fast and simple, which is both push and pop operation happen in constant time, fast and predictable. Next is minimum memory, which is memory efficient. Only essential action report are stored and not the entire state of the applications. Next is support for redo, which is using two stack, for one for undo and one for redo. Follow bi-directional navigation through the user action, enhancing flexibility. In short, stack are simple and very fast and perfect for this job for this Visual Code Studio. In conclusion from my slide, the undo and redo system is more than just a convenience feature. It's a great example on how smart design and data structure enhance usability. The stack is help application keep the track of guided action, reverse them, and even allow user to forward again. Uh, it used in text editor, graphic software, and spreadsheet, and even in video game. So when the next you when you hit the control Z button, we know how that behind the scenes and humble stack is doing all the hard work. And that's all from me. Thank you.
So for the code and output of the VS Code, so data structure with operations that have been discussed prior, which is the tree data structure for folder or file navigation operation, queue data structure for task scheduling operation, stack data structure for undo or redo operation. So under the first one, tree structure or for folder or file navigation. So the scenario is navigating project folders and files inside the Explorer panel, or the tree structure. So the code for the tree operation is in this TypeScript, and the output of the file navigator is there. So the output is the S sub C, which is the tree. Each of one of those represent a node. So the root node is coding exercise, and then the parent exercise with one, and then S sub C my array.java, the Java. So the collection class is the array that uses the tree node that is used for the children. Interface use is the tree node custom. So operations includes print tree, get children, traverse, and expand. So on to the next one, the queue structure for task or event scheduling. So the scenario is managing background tasks, file save, linting, and autocomplete. So the code for the queue operation is in TypeScript. The output of the task scheduling is there. So the collection class is the array string that acts as a queue. Interface use is the iterability array that is used implicitly. So the operations for this is enqueue, dequeue, and is empty. So on to the next one, the step structure for undo or redo system. So the scenario is tracking user edits for undo, which is Ctrl Z, and redo Ctrl Y. The code for the step operation is in TypeScript, and the output for undo or redo system is the button for undo or redo. So collection class is array string that is used as a stack. Interface use stack the array. Operation push, pop, and pick. So on to the next presenter.
To wrap up our presentation, I'd like to share the main conclusion from our project. First, this project clearly shows us how important data structure are not just in academic theory, but in real-world software like Visual Studio Code. This structure helps organize operation, improve efficiency, and make the user experience smooth. We start with the tree structure, which is used in VS Code folder and file navigation. This tree layout allows users to explore files in a clear hierarchy way. Each file or folder is unknown, and the navigation is made possible through algorithms like dig first or break first search. Next, we look at queues, which manage scheduling in VS Code. For example, when you save file or trigger background tasks, those operations are placed in a queue, execute one by one in the first in, first out order. This prevents new tasks from interrupting one that are already in progress. Then we explore stack, used in the undo and redo system. Stack follow the last in, first out rule, which make them ideal for tracking edits. When you undo an action, the most recent one is reversed. If needed, the redo stack allow you to bring it back, but operation happen quickly in constant time. These implementations are not only smart, they're efficient, with most operations running in O1 time. That's why they are chosen for formal critical systems like code editors. Finally, this project helps us understand why developers choose certain data structure. It's not just about what works, it's about what works best. And even though VS Code is a powerful tool, we notice a few areas like undo history limit, where improvement could still be made. Thank you.